which is essentially working backwards and finding inverse values for sine and cosine of the unit circle. If you recall, when we did the unit circle beforehand, before we were unable to, go to school, we talked about, say, 45 degrees, what were the sine and cosine values? And if you recall, x, y was equal to cosine theta sine theta. So now we're going to go backwards. So let's start by filling in the unit circle. So first we're doing degrees. On the next page we'll do radians. So if we focus just on degrees, this right here was 0, 360 degrees, 30 degrees, 45 degrees, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, and 330 degrees, which brings us all the way around to 360. We're back where we started. In terms of coordinate pairs, 1, 0, this right here was root 3 over 2, comma 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2, and this is 0, 1. So now we can really just follow the patterns around the circle. So if this is 1/2 root 3 over 2, equidistant over here, 90 to 60, 90 to 120. So this is also 1/2 root 3 over 2, only our x value is negative. All the middles here, the 45s, the multiples of 45, are root 2 over 2, root 2 over 2. In this case, the x is negative. The 150, equidistant as far as the 30, or you can think about reflecting it over the axis here. This is root 3 over 2, 1/2, so this is negative root 3 over 2, 1/2. This is negative 1, 0. 150 and 210, those sort of match, so to speak. So this must be negative root 3 over 2, negative 1/2. The 225 is another one of those in the middle. You can also look straight across here, the 45 to the 225. Either way, both of these are negative. Negative root 2 over 2, negative root 2 over 2. The 240 matches, so to speak, with the 120. So this is negative 1/2, negative root 3 over 2. 270 degrees is 0, negative 1. 240 and the 300 match, only this is a positive 1/2, negative root 3 over 2. Again, the positives and negatives just depend on the quadrant. 315 is one of those middles, so positive root 2 over 2, negative root 2 over 2. And by middle, I just mean cutting the quadrants in half. So this right here is in the middle between there and there. If that helps. And now 330. It matches with the 30 or with the 210 or any number of things. This is positive root 3 over 2, negative 1/2. So keep in mind, if we were still in school, I would have quizzed/tested you on memorizing the unit circle. As it is, since I'm not there to see you take a quiz or a test, you're not expected to memorize it. You'll just need to be able to use it. So for example, if I asked, what is the cosine of 60 degrees? You should be able to look at the 60 degrees and say, okay, well, here's the coordinate pair. So the cosine would be 1/2, and the sine would be root 3 over 2. That's what I mean by use the unit circle. So now let's get into kind of the purpose of the lesson here. we're finding inverse values. So if you recall, as we've talked about a couple times even today, cosine is x, sine is y. So if we're looking for when the sine of theta is root 2 over 2, we're looking for a y value. So essentially we're asking the question, at which angle is the y value square root of 2 over 2? And if we look around, the y value is square root of 2 over 2 for 45 degrees. And the y value is also root 2 over 2 for 135 degrees. So those are our two answers. Now number 2, we have a y value again. So we're looking at for which y value, for which theta rather, for which angle is the y value negative root 3 over 2. And you're really just looking around the unit circle and looking for the y value that's negative root 3 over 2. And this is true for 240 degrees. And it's also true for 300 degrees. Cosine is x. So where is the x value negative root 2 over 2? Looks to be 135 degrees. And also 225 degrees. Another x value. For which angle is the x value negative 1/2? Let's see, 120 and 240. Sometimes you're asked to find the general solution. Keep in mind that when you're looking at the unit circle, technically you can find coterminal angles by adding or subtracting 360 degrees. So if you are at 30 degrees, you go all the way around the circle again, now you're at 390 degrees. Or you could go all the way around the other way and you'd be at negative 330 degrees. So a general solution, so for number 5, sine of theta equals root 2 over 2, we already found this. This is a y value, and the y values were square root of 2 over 2 for 45 and 135. So then our general solution is 45 plus 360n and 135 plus 360n. All this means is, oh, our answer is 45, but you can also go around the circle as many times as you want in either direction. Our answer is 135, or you can go around the circle as many times as you want in either direction. Same is true for this next one. When was the y value negative root 3 over 2? We already found that. It was 240 and 300. So it's that plus 360n and 300 plus 360n. Same is true for 7 and 8. So cosine of theta was negative root 2 over 2, or the x value, for 135 and 225. So we add 360n, and we add 360n. Cosine of theta is 1/2, negative 1/2, excuse me. That was true here. So 120 plus 360n, and 240 plus 360n. So that's how we find the inverses, essentially, when we're doing degrees. We can also do radians, okay? Same idea. Let's fill in the radian values. This was 0, 2 pi, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and we're back for 2 pi. I went ahead and filled in the x and y values, or the coordinate pairs, for the unit circle, since we'd already done that on the previous page. And again, keep in mind, at this point, you don't need to worry about memorizing the unit circle. Future, possibly next year. Okay, so now this is very similar / the same. We're just looking for radian values. So for what angle is the x value √2/2? Looks to be pi over 4 and 7 pi over 4. When is the x value negative √3/2? Looks to be 5 pi over 6 and 7 pi over 6. When is the y value negative √2/2? Appears to be 5 pi over 4 and 7 pi over 4. When is the x value negative 1/2? 2 pi over 3 and 4 pi over 3. And when is the y value negative 1? 3 pi over 2. Back to general solutions. On this page, the examples down here don't directly align with the ones above, so we'll kind of do them separately. So if we're looking at sine of theta equals √2/2, we're looking at for which angle is the y value √2/2. Let's switch colors so we can kind of keep track. The y value is √2/2 for pi over 4 and 3 pi over 4. And on the previous page, we were looking at we were basically saying our answer was a degree, and we could add or subtract 360, go all the way around the circle. Well, now all the way around the circle is 2 pi, because we're talking radians. So it's pi over 4 plus 2 pi n, or 3 pi over 4 plus 2 pi n. I'm not sure I mentioned this before. N is just the number of times you're going around the circle. You're not necessarily going to calculate anything with this. Just know that technically your answers are pi over 4 and 3 pi over 4, but you can go around the circle either way, however many times you want. Looking at the next one, when is the y value negative √3/2? It looks like it is 4 pi over 3 and 5 pi over 3. So then our answers are 4 pi over 3 plus 2 pi n and 5 pi over 3 plus 2 pi n. Looking at number 16, cosine is x. When is the x value negative √2/2? Well, 5 pi over 4, 3 pi over 4. And then you add 2 pi n. Do one more. When is the x value negative 1/2? The x value is negative 1/2 over on this side. So it looks like 2 pi over 3 and 4 pi over 3. So then our answers are 2 pi over 3 plus 2 pi n and 4 pi over 3 plus 2 pi n. Do these bottoms examples on your own and check it with the key that I've posted in the folder with this video. Keep in mind with general solutions, you don't need to overthink the 2 pi n or the 360n too much. Just tack that on at the end when it's general, because it takes into account that you have coterminal angles to deal with.